And to think, each one of those 100 billion stars has its own planets, its own strange worlds. Imagine what it would be like to visit some of those exoplanets beyond our own little solar system. Well, today, you don't have to imagine, because I'm going to take you on a tour of 6 real exoplanets. What you're about to see is based on the latest scientific research, and as we travel across the cosmos, we'll hear astrophysicists from the University of Exeter tell us about their search for planets beyond our solar system. So, if you want to experience what it might be like to stand on another planet, I highly
4 or 5.
and strapping on. Okay, are you ready? Let's go.
I'm Elizabeth. I'm studying observations of debris disks and trying to find debris disks and giant planets. So the planets will form over maybe 4 or 5 million years as the star forms. So the star forms out of a massive cloud of dust and gas, and that collapses down, and the centre of that will fall inwards and become a star. But then there'll be a whole cloud of dust and gas and stuff left, and that kind of collapses down into a disk that's just made out of kind of the leftovers from the star formation. And then that disk, the individual bits of dust will collide to each other, and they can sometimes stick together. We don't really understand that yet. Sometimes they stick and sometimes they bounce off, and no one really knows how they can stick together enough to start to form a planet. But then as soon as you have a big core, we call it a planetesimal, so it's maybe 10 to the surface.
So I'm Professor David Singh, and I study transiting exoplanets and their atmospheres. Well, hot Jupiters are gas giant exoplanets, but they orbit much, much closer to its star, thousands of or so richer.
My name is Stefan Lines. I'm an exonephologist,
which is someone who studies clouds on extrasolar planets. So what we're looking at is planet Osiris, otherwise known as HD 209458b, and these are extremely strong winds, going from the of around temperature iron rays.
My name is Nathan Main, and I study the atmospheres of planets
we've discovered around distant stars. Our next destination is the surface of a water world. This is a super Earth, as it's called. In our own solar system, we have no planets which exist in the size range between Earth and Neptune, but actually as we observe off into the galaxy, we find this is one of the most common form of planets. We think that many of these have kind of rocky cores. They're terrestrial planets essentially, but they're likely to have a huge ocean. Now they're super Earths. They're much larger than Earth. They might have much stronger gravity, and they probably have much thicker atmospheres. That means any land features that are on these planets, any rocky features, are going to be weathered and suppressed and effectively destroyed. You can see this. So many of these planets we expect might be undergoing.
Our next destination is the surface
of 55 Cancri e. This planet orbits so close to its central star, it's incredibly hot. We think temperatures of a few thousand Kelvin or a few thousand degrees. We know from how much this planet wobbles its star due to its gravitational interaction that this planet is about 8 times the mass of the Earth. And we also know from its sort of transit, when it eclipses the central star, that it's probably about twice the diameter of Earth. So this planet is incredibly much of that material, significant thunderstorms. So effectively
constant.
My name is Jessica Spake, and I'm interested in studying exoplanet atmospheres. TRAPPIST-1e is a fascinating system. It was a wonderful surprise to find 7 fairly Earth-sized planets so small.
Thanks for watching.